In this video, let's see the radius of curvature proof in polar form. To construct the geometry, r is equal to f of theta be the equation of a polar curve. So this is the curve p r comma theta, where OP is nothing but the radius vector, that is the distance from O to the point P, and phi be the angle made by the radius vector with the tangent. So this angle, I'll mark it as phi, and let me write phi is the angle between radius vector and tangent. Let psi be the angle made by the tangent P with the initial line. Made by tangent at P with initial line. What is the initial line? That is, this is the initial line. And here at the point P, we are drawing a tangent here. This tangent hits the initial line at an angle psi. So this angle we have written as psi. And this A be any fixed point on the curve. Okay. So A is any fixed point. I'm just marking this point as A. And this arc length AP, this will denote like this. This is the arc length AP is equal to S. Now, with the geometry, the psi I can write it as theta plus phi. So exterior angle is equal to, this is the exterior angle, sum of interior opposite angles. So when I say P of r comma theta, the distance from O to the point P is r, and this angle is theta. So psi is equal to this theta plus phi. Now from this, we are going to calculate further ahead. If I differentiate this with respect to S, I can write this as d theta by ds plus d phi by ds. Now the first one I'll keep as it is, d theta by ds. This d phi by ds, I'm going to differentiate d phi with respect to d theta and then d theta with respect to ds, like a chain rule. Now if I substitute, already we know that d psi by ds is nothing but 1 by rho. Right hand side I can take d theta by ds common. This is 1 by rho. This d theta by ds is there in both the terms. If I take this common, what I will get? 1 plus d phi by d theta. And already in the basic definition, we can say this tan phi is nothing but r into d theta by dr. So r I can write it as r by dr by d theta. So this is the fact. We know that tan phi is r into d theta by dr. This I can write it as r into dr by d theta. This I'll name it as r1, where r1 is dr by d theta. First derivative means r1, second derivative means I'll write r2. If we differentiate the above equation with respect to theta, we get, so tan phi differentiation is secant square phi, but we are differentiating with respect to theta. So secant square phi and then d phi by d theta. Tan phi if I differentiate, secant square phi. Since I differentiate with respect to theta, this extra term d phi by d theta is coming. Now this is nothing but u by v rule. What we will do in u by v rule, keep the denominator r1, differentiate the numerator. So numerator is r. R if I differentiate again, I will get r1 minus, keep the numerator is r, and then differentiate the denominator. If I differentiate r1, second derivative, I'll write it as r2. So r1 is dr by d theta means r2 is d square r by d theta square. And divided by denominator, the whole square. So this is simple u by v rule. And if I rewrite this, we can write d phi by d theta is equal to r1 into r1 is r1 square. minus r into r2 divided by r1 square. This, okay, just we have simplified and written. So r1 is nothing but dr by d theta, and your r2 is d square r by d theta square. Now what we are going to do is just simplify this term, and before simplifying, this secant square phi is there. I am bringing it here. Now it is easy. The numerator is r1 square minus r2 divided by r1 square. The secant square phi here, we got it down. This I can write it as 1 plus tan square phi. Why I am changing in terms of tan? Because this tan already we know what is tan phi. R by R1 I know. I can substitute and change everything in terms of R. So R1 square minus R into R2 by R1 square into 1 plus. Already we have derived tan phi as R by R1. So what is tan square phi? R square by R1 square. This is. Now we are going to take LCM. If I take LCM, what I will get? R1 square minus R into R2 divided by R1 square into, if I take LCM, R1 square plus R square by R1 square. We are taking LCM for this second term. And this R1 square and this R1 square will get cancelled. And left hand side we have d phi by d theta. I'll rewrite it again. D phi by d theta is equal to r1 square minus r into r2 divided by r1 square plus r square. Now what we are going to do is we are going to add 1 to both the sides. If I add 1, 1 plus this thing is equal to 1 plus. So add and subtract in one side or add to both sides. Now again I have to take LCM. If I take LCM, r1 square plus r square plus r1 square minus r2 divided by r1 square plus r square. Now if you see the numerator 2r1 square is there. This and this I'll write it together, which is, so first I'll write r square. This term I'll write first. We have 2r1 square minus r2 divided by r1 square plus r square. What is there on the left hand side? That is 1 plus d phi by d theta is here. Okay. Now, what do we know about ds by d theta? ds by d theta, we can take it as a direct formula, r square plus dr by d theta the whole square. This is the formula for ds by d theta, r square plus r1 square. Now what we are going to do? We are just going to substitute this using this 1 plus d phi by d theta, this equation, say A, and this equation, we are going to substitute in the main one. We have written rho is equal to ds by d theta divided by 1 plus d phi by d theta. This we wrote in the beginning. We started our formula like this. Let me show you. Before taking tan phi. This equation. So this equation, name it as equation 1. Why we are doing all these things? Why we have added 1 plus means because in your formula 1 plus is there. What I will do, I'll find d phi by d theta and finally I've added it to 1 and I have written what is d theta by ds. We are going to substitute everything in this main equation. As simple as that. So tan phi is this. If I differentiate secant square phi, from this I will get d phi by d theta. This term. This term is there, no? D phi by d theta. This is this. After simplifying this, I am adding 1 so that I will get 1 plus d phi by d theta to substitute here. So we'll be wondering why I am adding 1 to both the sides. Huh. After finding d phi by d theta, I'm adding 1 to both the sides. Now, we will substitute this and ds by d theta in this main equation. So ds by d theta is root of r square plus r1 square, and 1 plus d phi by d theta, we got it already. This, if I substitute divided by, the denominator will go to the numerator. This term, I am going to substitute divided by r square plus 2r1 square minus r2 divided by r square plus r1 square. I can write it as any format. This will go to the numerator. Both the terms are same. One is power 1 by 2. The other one is power 1. So rho is equal to r square plus r1 square. Root 2 means I will write this as 1 by 2. This is power 1. What we will do? We will add the powers divided by r square plus 2r1 square minus r into r2, and 1 by 2 plus 1 is nothing but 3 by 2 r square plus r1 square power 3 by 2 divided by the same terms. This is the formula for radius of curvature in polar form, minus r r2. And here this is very simple. If I have root 2 into 2, this is nothing but 2 power 1 by 2 into 2 power 1. So 2 power 1 by 2 plus 1, that is 2 power 3 by 2. Same way we have added the powers, and this is the formula for the radius of curvature in polar form. The next video, let's solve one or two problems based on this. Thank you.